Welcome to Chemistry Solutions. This is a GCSE revision video and it's taken from section 4.3 of the AQA syllabus on quantitative chemistry, and it's specifically about balancing chemical equations. It's relevant for all exam boards. Please feel free to pause the video as often as you like and as often as you need to. To balance equations, you have to understand the law of conservation of mass. Pause the video and write down what you think the law of conservation mass is, and then compare it when you restart the video. The law of conservation of mass states that no atoms are lost or made during a chemical reaction, so the mass of the products equals the mass of the reactants. If no atoms are lost or made during a chemical reaction, this must mean that the number of atoms on either side of an equation must be the same. Let's look at this example. 2H2 plus O2 goes to 2H2O. There are 4 hydrogens on the left, 2 oxygens on the left of the arrow. On the right, there are 4 hydrogens and 2 oxygens. We'll explain more later how we get these numbers, but this is what the law of conservation of mass is about, and it's important and vital when you're balancing equations. And let's have a look at what the numbers mean. The big numbers in front of these elements here, you can see the red 2. These big numbers in front are called coefficients, and all atoms to the right of a coefficient are multiplied by that coefficient. So imagine that there's a bracket round a molecule. You would in maths. So let's look at this another example here. 2H2O. The 2 is multiplying the molecule water. In other words, we've put a bracket round the water. So everything in the bracket has to be multiplied by 2. So 2 2s are 4, so we get 4 hydrogens, and then the 2 multiplies the oxygen to get 2 oxygens. So what do the little numbers mean? The little numbers are called subscripts, and these multiply individual atoms or groups, as you'll see in a minute, immediately to their left. So if you look at this example here, we've got H2, so that 2 is multiplying 2 hydrogens. And then the 2 next to the oxygen, that means we've got 2 oxygens. What about this one? Pause the video and see if you can work it out. So the 2 in front of the hydrogen means we've got 2 hydrogens. There's no number next to sulfur, so that just means 1, like in maths. And then you've got a little 4, subscript 4, so that means we've got 4 oxygens. So altogether, 2 hydrogens, 1 sulfur, 4 oxygens. Did you get it right? And finally this one, magnesium nitrate, MgNO3 twice. We've got 1 magnesium because we've just got the 1 number, no number, so that means it's 1. Inside the bracket we've got 1 nitrogen and 3 oxygens, but this is actually a bracket that's got a 2 next to it, so everything in the bracket now has to be multiplied by 2. I know it's complicated, but you'll get used to it. So if we have 1 nitrogen multiplied by 2, that gives us 2 nitrogens. 2 times 3 for oxygen gives us 6 oxygens. So let's crack on and look at some balancing. So let's just remind ourselves what equations are all about. In this example here, the chemicals in blue before to the left of the arrow are called the reactants, and then the products are on the right hand side. These are the products in red. So we have this imaginary line down the middle. To the left, the reactants, to the right, the products, and we'll refer to the left of the equation or the right of the equation, or we might refer to the reactants and products. But in an equation, all these numbers must all add up. Let's have a look at an example here. Mg plus O2 goes to MgO. So we write underneath the individual atoms, Mg, 2 O's and an MgO on the right. So we can see straight away that we've got 2 oxygens on the left and only 1 on the right. But we can't put a 2 there. No, that's not allowed because that changes the formula. We have to double the whole thing. So we have another MgO. Now look, it means we've got 2 Mg's So we have to write another Mg under there. So if we look at this now, it balances 2 Mgs, 2 Os, 2 Mgs, 2 Os. So at the top here, we've had to add an extra Mg. So we put 2 there and a 2 there for MgO. Let's try a similar one. K plus Br2 goes to KBr. So we write out the atoms, K, 2 Brs here, and on the right-hand side, a K and a Br. So we can see, again, like the previous one, we've got 2 Brs on the left and only 1 on the right. We can't write that little 2. We have to double the whole thing. Now we've got 2 Ks, so we put an extra K here. That balances, tick, tick, tick. They all balance, so we've added another one, so we have a 2 Ks and a 2 KBr, and it all balances. So let's try a slightly more complex one. We've got N2 plus H2 goes to NH3. So let's write out the individual atoms. 2 N's here. Then we've got a H2 molecule, so 2 H's there. And on the right-hand side, an NH3 molecule. So we've got N and 3 H's. So let's look and see, where do we start? Yeah, let's have a look. We've got 2 nitrogens on the left there, but we've only got 1 on the right. Now remember, we can't put a little 2 in there. We've got to double the whole molecule. So we write the whole thing out again, N plus 3 H's. So now we can add these up now, because it's getting a bit complicated. So we can tick nitrogen's balance. So on the right, we've got 6 hydrogens, but on the left, we've only got 2. So we have to multiply that molecule by 3, because 3 2's make 6, and then it should balance. So let's add them up. We've got 6 hydrogens here on the left, and then we've got 6 on the right. The whole thing balances. And here's our 3 molecules of hydrogen here. So what we're going to do now is sub the numbers in. So here we've got 1 nitrogen molecule, so that can stay the same. We've got 3 hydrogen molecules, so we put a 3 there, 2 ammonias, 2 there, balances. Jobs are good. So let's look at a more challenging one. The next one is one with 2 reactants on the left and 2 products on the right, and it's a hydrocarbon combustion one. We often get these in the organic chemistry section. So let's look at a plan to tackle this. Now, there's an order that we should do this in. We should balance the carbons first, then the hydrogens, and then the oxygens, and you'll see. So we do exactly the same thing. We write out the individual atoms, CH4, O2, CO2, plus H2O. So let's look at the carbons first. On the left-hand side, we've got 1 carbon. Bingo. On the right-hand side, 1. So far, so good. Carbon's done. Hydrogens, 4 on the left. 1, 2, 3, 4. On the right-hand side, we've only got 2. Remember, we have to double the whole thing. So we have to have 2 water molecules. So we have another HO. So how many hydrogens? We've got 4 there. That balances 4 there. We can tick the hydrogens off. Bingo. Now let's look at the oxygens. On the right-hand side, we've got 2 in the CO2 and 2 from this doubled up hot water. So we need another 2 oxygens. So we've got 2 molecules of oxygen. They now balance. 4 there, 2 there, and 2 there makes 4 on the right. So now we put the numbers in. We haven't changed the methane, the CH4, but we've doubled up the oxygens. So we need a 2 in front of the oxygen. We've not done anything with the carbon dioxide, so that can stay the same. And we've doubled up the water, so we need a 2 in front of that water. So let's look at another hydrocarbon combustion problem. Balance this one. C3H8 plus O2 goes to CO2 plus H2O. So we follow exactly the same principle. We do the carbons, then the hydrogens, and the oxygens. So let's write out the individual atoms in each molecule. You've got C3H8 there. Then you've got your O2. Then you've got your CO2 and your H2O. So if we look across at this is propane, the C3H8. Some of you maybe spotted that. We've got 3 carbons, so we need to treble our 3 carbons at our carbon dioxide. Remember, we must treble all of it. So we have 3 carbon dioxides. Now our carbons are balanced. We can tick them off. So let's have a look at hydrogens. There's 8 on the left. So we need to make sure we can 8 on the 4. The only way on the right we do that is by multiplying the H2O by 4. So we get 8 H's on either side. Now the final one, the oxygens. So on the left-hand side, we've got 2. On the right, we've got 6 for those 3 CO2s and 4 for those H2Os. 6 and 4, that makes 10. So we've got 10 hydrogens on the right. We need 10 on the left. We've already got a molecule containing 2. So in other words, we need to make that from a 2 into a 10. And to do that, we multiply by 5. So we have 5 molecules of oxygen. So let's look at putting the numbers in. The CH3H8 stays the same. We've just said we've got 5 oxygens. If we count the CO2s, we've got 3 of those, and we've got 4 H2Os. Balanced equation. Now, this next one is extremely challenging, and to be honest with you, you'd be very unlucky if this one came up. It'd be very rare to get one of this complexity, but I've included it because I wanted to show you that the method that we use works. So bear with, have a go, see what you think. The equation is ethane plus oxygen to carbon dioxide and water. C2H6 plus O2 goes to CO2 plus H2O. So we put down our carbon, hydrogen and oxygen and we balance in that order. So again, we do exactly as we've said before. You write out the molecules in the individual atoms. So we've got a C, 2 C's, 6 H's. The rest of it is as we've done before. Your 2 O's, CO2 and H2O. So let's look back at the C2s. We've got 2 carbons here, so we need 2 carbons on the right-hand side. So we have to double the whole molecule, so we need 2 CO2s. The carbons balance, we can tick those off. Let's look at the hydrogens. On the left, we've got 6. There we are, 6 hydrogens. On the right-hand side, we're starting with 2. To get from 2 to 6, we multiply by 3. So we need 3 lots of H2O. So we have our 6 hydrogens now. They're balanced. Tick that one off. So let's go to the oxygens. On the right-hand side, the oxygens are 4 here and 3 here. Now look at this. 4 and 3, as we, no surprise, makes 7. So on the right, we've got 7 oxygens. So we must have 7 on the left. So let's just write them out. You know, that's all we can do for now. 2 already, 3, 4, 5, 6, 7. Now look, we've not got an even number, and that always causes a problem. We've got 3.5. So if you look there, we now are 7 on the left, balanced our 7 on the right, but we've got 3 molecules plus a half a molecule, and you are allowed to use fractions. So the ethane stays the same. We need 3.5 O2s. Nothing on the front of that one. We've got 2 CO2, so a C2 goes there. And here we've got 3 H2Os, so we put a 3 in there and the equation balances. Thanks for watching. I hope you enjoyed it. I've got more videos like this for revision. We've also got exam walkthroughs, chemistry walkthroughs. If you click on my site, you'll be able to get those. And we'll see you next time.